So today we're going to talk about properties. Make sure you grab out your properties foldable from your portfolios. They're in a box in the back corner if you haven't done so already. They look like, I'll change the slide. They look like that, and I know it's kind of hard to see, but you'll have a copy of your own in a minute, so you'll be able to look at it. So pause the video if you need to get it, or keep going if you don't. So your objective today is to use mathematical properties to justify methods for solving equations. Actually, we're going to simplify expressions today, but we will be solving equations soon. So first, we're going to talk about what an equivalent expression is. There are expressions that have the same value, but they don't always look the same. So, for example, 4 times 12 plus 4 times 8, that expression is the same as, or is equivalent to, 4 times the quantity, 12 plus 8. Okay, and I can prove that in a few different ways. I could say that this is a distributive property, or I could actually do the math and prove that they were equivalent. So this right here, remember your equal sign does not mean answer, it means the same. So whatever's on the left is the same as what's on the right. So today you're going to be writing equivalent expressions and using properties to justify solving them or simplifying them. So let's review the properties. And this is a little tricky to see, but this is just the front of it. Remember, we have the commutative properties of multiplication and addition right here in the top two. Then we've got the associative properties of multiplication and addition here. We've got the identity properties and the distributive properties. So on the next slide, I'll go over them. If you couldn't find your copy, make sure you look on with a neighbor. Okay, so I kind of zoomed in a little bit here. So we're going to start with the commutative properties. Remember, commutative means to commute, to change position. So we're kind of just rearranging the problem to be more useful for ourselves. So remember, order doesn't matter in addition. It has to be addition. Can't be addition and multiplication. It can't be addition and subtraction. If you only are working within addition, you may use that. And same with multiplication. If it's only multiplication, then you may switch the order of things. But you can't have mixed operations. And then we've got the associative properties, which is very similar to the commutative property, except for we're changing the grouping of things. So remember, associative property is all about groups. So you're looking for your grouping symbols and changing the order there. So like down here I had 25 plus the group 75 plus 7, which means I'd have to do 75 plus 7 first, which isn't that hard, but you know what's really much easier? 25 plus 75 is 100. So we can rearrange these using these two properties. We can rearrange things so that we can solve them in an easier, more like mental math kind of way. Okay, we also have the identity properties, which they come into play a lot more in a couple years, maybe next year when we do 8th grade math, because right now it's kind of like no duh, anything plus 0 is itself. But remember, 0 can come in multiple ways. So 0 can look like this. I can say 8 plus 10 minus 10. And even though I didn't write 0, I know that this is 0 right here. So I know the answer is 8 because of the identity property. Okay, so we're going to see it come up in a little bit more of a complicated way next year. And the same goes for for the identity property of multiplication. Anything times 1 is itself. We use that all the time when we are enlarging fractions or simplifying fractions. If I take the fraction 42 over 12 and I simplify that, I'm going to divide by 1. I'm just going to write it in a different way, but this right here is really 1 because I don't want to change the meaning of 42 over 12. I just want to reduce it, which it's really, 7/2. Okay, so I'm using the identity property there to simplify. And then we have the distributive property, which just means if I'm multiplying by a group in algebra, 3 times, I think this one says 4x plus 7 or something like that. Doesn't matter. Here's a new problem. I have a number times a group, but I can't add these together. They're not like terms. So then I can use my distributive property to make a more simplified problem, because I know I can multiply this and this. So 3 times 4x, 12x, plus 3 times 7 is 21. So I've gotten a little simpler format. Also, the distributive property is used in mental math all the time. We use it to rearrange kind of things so that we can easily put them together. So like, I think the other day we did a problem that was 99 cents times 6. I guess I don't need this parenthesis here. And this one I use to I use mental math and distributive property to solve this one quickly, because I know this is really $1 take away 1 cent. Oh, that's 10 cents. 1 cent. That whole thing times 6. So I really know that it's $6 take away 6 cents. Well, $6 take away 6 cents is $5.94. So it makes that math a lot more simple if I can figure out how to break up a complicated number into 2 simple things. And then of course you can do it with adding, and the example in your foldable is a fraction there. We have 3 times 4.5. We can use our distributive property to break up 4.5, so it's really 3 times 4 plus 1/2. So now I can do 3 times 4, which is 12, and 3 times 1/2 is 1.5. So I have 13.5. So that's how we use it to do mental math all the time. Anybody who's good at it knows how to break stuff up like that. And you might even do it naturally, but now you have a reason. You're using the distributive property. So today when it asks you to do mental math in your homework, I want to see how you've broken up the number and how you're multiplying. And since I can't read your mind, you can't actually use mental math on your homework. You have to show me what you're doing in your head on your paper. So mental math means show me what you would think on your paper. Okay, moving on. So the Tour de France is a cycling race through France that lasts 22 days. If a cyclist averaged 90 miles per day, how far does he travel? Use properties within your answer. So I know that you guys can solve this in no time. It's not hard. But I want you to use your properties to find another way to solve it. Because I know I can just do 90 times 22 and do the math and da-da-da and add them and whatever. Okay, that I know you can do. What I want you to do is use a property. So, for example, on this one, 90 times 22, I have 90 is not too complicated number because it's 9 and a 10. So 22 we can break up into something a little easier to deal with. 90 times 20 plus 2. So take 22 and break it up into its place values, 20 plus 2. And then you can more easily figure out the answer. It's 90 times 20, which is 9 times 2 with some zeros. So that's 1800. And 90 times 2, which is just 9 times 2 with 1 0, so that's plus 180. And then you can add those numbers together, which is, 1,980. Okay, and then you can go ahead and write your answer. So how far do they travel in the Tour de France? Oh my goodness. So the cyclists travel 1,980 miles. Wow, that's a long way. I can do 40 miles in one day, but then I can't do any more the next day. So that's impressive. Okay, so I expect to see you using your properties. And what property did I use right here? The distributed property. Okay, so make sure that you're not just doing whatever you would to solve it. We're studying properties, so I want you to attempt to use them. Okay, and then here it says evaluate mentally and justify, but keep in mind, I can't read your mind and I don't think you want me to. So, make sure to pick a property and use it for each problem. Okay? So looking at this, I have 40 times the quantity, 7 times 5. Okay, so looking at this one, I have to look at it and I go, okay, well it's all multiplication. So I can use a commutative and an associative property. Okay, those are my, or an identity property, but I don't see a 0 there, or a way to make a 0. So we're using the commutative or the associative property. So you have to decide, do you want to move some groups? Do you want to deal with the parentheses? Do you want to deal with the numbers? Do you want to do both? So what do you want to do? I'm looking at this and I like 4 times 5 is easy for me. So I want to do 4 times 5. So I'm going to just take 40 times, and I'm going to change it. I'm going to flip what's inside the group. That's me changing places. I did not change the group. The numbers in the group are the same, but the places are different. So I use the commutative property. Now, I got my 40 next to my 5, but I still have 5 and 7 in a group, which means I have to do that first. So I do want to change the group because I want to do 40 times 5 first because that is easier for my brain. So I'm going to change what's being grouped using the associative property. And now I'm ready to just solve it using my order of operations. So 40 times 5 is 20 plus an extra 0 times 7. And right there, I'm just using order of operations. And lastly, 200 times 7, well, that's 2 times 7, which is 14, and 2 place values on the end. So that was just multiplying. 200 times 7. Okay, so it's important that you use at least one property in each of these problems, showing how you would do it. And this is how I would do it in my head. Of course, it would go a lot faster if I did it in my head. But I'm proving to you, you're going to be proving to me how you would do it. There's more than one way to do it. So just keep in mind, as long as you're using one of the properties correctly, you are fine. So I'm not going to go over this. I could have just done one of those two things if I wanted. Okay, so I'd like you to try this one. So use a property to simplify this. Make sure you show your justification on each step. So pause the video and you try it. Raise your hand when you're done. Once you've completed the you try, you can go ahead and start your homework. And make sure I will be checking to make sure you use properties because that's the whole point of today. So make sure you do that in your homework so when I come back you don't have a whole bunch of homework to redo.